What's up everyone, Tom from the Airsoft headquarters here, and welcome back to 5-Minute Fixes, where I try to answer all of your questions or concerns that you may have about a specific topic or part that is part of your gun or gear. So today we're going to be looking at air volume assembly, asked about by a subscriber. Thank you very much. And then what we're going to do is we're going to talk about parts, things that you should look for as far as tolerances, as well as possibly looking at upgrades and what you should be looking at when you consider purchasing parts for upgrades. So we're going to start the timer now. Air volume assembly. So what does that look like? Well, it's going to be made of 4 different parts inside of the gearbox, and the 5th is going to be the hop-up assembly. Now these are all going to be made up of different parts from different manufacturers, and are even going to be dependent on the version of gearbox that is inside your airsoft rifle. We are going to be looking at the most common of air volume assemblies in the version 2 gearbox, otherwise known as the M4 style of air volume assembly, or M4 version 2 gearbox. So part number 1 we're going to be talking about is the piston head. So the piston head is going to sit on top of the piston and is going to dictate the amount of air compression that is inside of the cylinder. Now the cylinder is going to be this metallic cylinder. The piston is going to reside inside of the cylinder, and it is due to the O-rings to compress inside of the cylinder in order to dictate the amount of air volume that's inside of there. It also is going to dictate the amount of air volume going through that cylinder dependent on where that piston sits in relatively to the spacing of the front of the cylinder. So if someone is using a DSG or even a shortened tooth of a gear ratio, that piston is going to have less space or less air volume in order to compress to get that air volume behind the BB. So an 18:1, or generally 18:1 is the most standard. There are higher ratio of gears that allow for the piston to sit right at the lip of the cylinder, or even have that cylinder extend for enhanced air voluming. There's even DSG or shortened gear ratios that don't allow for the piston to sit as far back as possible, resulting in as little air volume as possible going out behind that BB. So there's a couple pros and cons with each one. When it comes to the higher ratio of gears, it allows for the most amount of air, which results in the most amount of volume to travel down possibly the longest amount of inner barrel in order to go for a long distance or a 20-inch barrel assembly, or even going with a wide bore inner barrel setup. Why would someone go with a shortened gear assembly? Well, if someone wants a fast trigger response or a high rate of fire build, they're going to have that piston sit as far forward in order to have the least amount of gear movement, resulting in the highest rate of fire. However, the caveat or the trade-off to that is they don't get nearly as much air volume, and thus they are restricted to the weight of the BB as well as the length of inner barrel that they can optimize for that current build. Now, what is the next component? And that is going to be the cylinder head, which sits here and is going to sit on the very front of the cylinder like so. And so the piston is going to move, slam onto the very back of the cylinder head like so, bam, bam, bam. And that allows for the O-ring on the cylinder head and the O-ring on the piston head to dictate the amount of trapped air volume that is going to force its way through the nose or through the smaller cone of the cylinder head. Now the cylinder head is also going to have an extra piece on here, which is the nozzle. The nozzle is going to sit on the end of the cylinder head, and this is what is going to push the BB up into the hop-up unit, which there could be O-rings on the inside of the nozzle assembly here to allow for even more compression so that air only can go through one direction, which is through the nozzle. And then the nozzle is going to sit inside of that hop-up unit and can even press that BB forward to allow as tight of a setup as possible. So that is 5 total components: the piston head, cylinder head, nozzle, and hop-up unit. Now, the best way to get the best amount of compression is to go with all of the same brand of components in order to guarantee, or at least make sure, that you get as tight of a tolerance between all of those 5 different components. If you do not have access to those, then it's kind of just a guess and kind of see if these things really will adhere to each other and get a really tight fit. If you don't get a tight fit, you do risk of losing air volume, or at least any amount of air that will go behind that BB, which is going to result in loss of BB distance as well as a loss of velocity. So I've seen it often where a part as simple as a non-properly spec'd of hop-up unit that does not correlate with the same brand of nozzle or cylinder head or cylinder will result in a loss of even up to 100 feet per second. I know that this is common with a lot of people that want to upgrade their hop-up units in order to get better range and accuracy. However, they should really be cognizant of the fact that they really need to get something that is going to work with the brand of parts that are already installed inside of the AEG gearbox. That will just allow for the best velocity to get that BB as far as possible. Sure, you can get a really good hop-up unit, but it's not going to do you any good if you're only hopping BBs at 250 feet per second, or in a very rare case, even less than that. So, as long as you can guarantee that these parts are going to work together and get the desired outcome, then you're actually going to be better off. All right, so some of the things that you should be aware of when looking to either upgrade parts or look at replacement parts for the air volume assembly, we're going to stick with the 18:1 ratio of gears for the example. So an 18:1 gears gives you about the set amount of air volume inside of here. So with an 18:1, that is roughly going to give you about 14.5 inches of inner barrel length at a 6.05, if I remember the math correctly, if I recall doing it several years ago. So if you try to go with anything longer than a 14.5 inch inner barrel, the problem is that there is only enough air volume inside of that air volume assembly to get the BB up to a couple inches of the end of that barrel. By that point, there is not enough air volume in order to push that BB any farther forward. So what happens is that creates a vacuum effect. And so now the amount of air volume has a negative pressure compared to the exterior of the inner barrel. So what does physics require? It requires that there is air that comes in, pushes past the BB in order to back up the amount of air here to be equivalent to the exterior air pressure, which means that now there is air being forced against the motion of the BB, which actually slows down your muzzle velocity even more, resulting in a lower velocity than what is expected. Sure, you can counteract this by putting a higher tension spring in there. However, you are overworking the system for something that really does not need to be overworked. So that is a no-go. You should not be doing that. You can also, again, with that 18:1 gear ratio, you can also have too short of an inner barrel if you are still using a full size of piston head. That again allows for the system to overwork because now there is an excess of air volume, so that once that air pushes that BB out of the inner barrel, there is now too much air volume, and now air is spilling out and is being wasted. You are now overworking your internal assembly and creating an excess of wear and stress. This is not nearly as bad as a performance compared to overvoluming, but it is something that is something you should be aware of. So again, something you can be aware of and something you should really not do. Ideally, you would perfectly match the your inner cylinder, your air volume assembly inside of your AEG to match the preset inner barrel volume that you can do with basic mathematics. If you match that perfectly, that will mean that there is only a little bit of air squeaking out of the side here, and you get the optimal performance and the least amount of stress on the internal workings of your rifle to get that BB out of the inner barrel with as little effort as possible to get the best amount of range and performance from those preset internals. Whew. Everything now changes when you want to go either up in gear ratio or down in gear ratio, which I feel like that may be a totally separate video, but now you know exactly what to look for and what the effects are and some of the things you know to ask when it comes to things resulting with higher gear of ratio or lower gear of ratio. So don't be afraid to ask those questions down below, and that actually gives us a whole nother video because I'm very certain that we went over our 5-minute limit. So I'm gonna cut it short right here. So put your questions down below. You guys take care, stay safe, stay positive, and I'll see you in the next one. Take care.